So if we focus on today's objectives, we've been talking about quadrilaterals and the different types of quadrilaterals. We first talked about kites. Yesterday we looked at trapezoids. Today we're focusing on which shape? Parallelograms. Okay, so objectives. Today we're going to develop different properties of parallelograms, and then we're going to use those properties or those theorems to actually solve problems that are involving parallelograms. For instance, like by the end of today, this is where we're going. Okay, if I just showed you these shapes, would you know right now enough about a parallelogram to be able to find every one of the angle measures, all the different side lengths? Some of these are diagonal pieces and parts. Do you totally know every property of a parallelogram yet?
No.
Maybe you know a few, but probably not all of them. So we're going to investigate a few more things in detail about parallelograms. So by the end of the lesson, you will be able to solve those problems. So for right now, just kind of stop and do a little quick write about what you do already know about a parallelogram. There's probably something that you know. Okay, I just even showed you some pictures of it. If you look at the picture, or you know something about it's a quadrilateral, you can jot down whatever that is. Think about parallelogram, right? Think back to maybe middle school or years past, whatever you know about parallelograms. Just kind of write down for me whatever it is that you already know.
Write down, no pictures?
You can draw, you can illustrate something.
Illustrate.
What are some things that you do know right now about a parallelogram? I saw a lot of different pictures, so I know you know some things. Ben, what's something you wrote?
I think that they have two pairs of parallel sides.
Okay, a lot of people mentioned the word parallel. Who else said something about that? Okay. What's something else maybe besides having two sets of parallel sides? Anybody say something else about it? Some people mentioned the word, it was a quadrilateral. So what does that mean? It has four sides already, so we know that. And actually, guys, what you just said is our definition of a parallelogram. So a parallelogram, let's define it. It is, what we said, it's four-sided. So it is a quadrilateral with some other little more specific properties. So it's a four-sided figure with two, well, Ben had said we had
Two pairs of parallel sides.
two pairs of parallel sides. And for those sides to be parallel, they're going to be the opposite sides that are actually parallel. So it has,
So if you have two sets of parallel sides, you know how you put the triangle on the line? It's an arrow, like the arrow on the line. Do you have to put two arrows on a line that isn't parallel to it? So like, let's say if you know how you do equal sides and you put one dash and whatever you equal to that line with the one dash, you have to put a one dash.
okay, so Muhammad was saying, he's asking this. If we have one set of parallel marks with like one set of arrows, right?
And there is nothing good to me, right?
So if the other lines are parallel, are the other two opposite sides, are they parallel with the ones I have marked right now?
Yes.
No.
The other with each other.
With each other they are, but not with the ones that are marked. So we don't want to say that they're parallel to something with one mark. So we want to put two. Okay, so these would have two arrows to show that these are the opposite sides that are parallel.
Does it matter what direction your arrows point?
No.
Okay.
In that definition box, it's also showing us the symbol. Here's our symbol for parallelogram. So just like triangle has the triangle symbol, before we would say triangle, ABC, this is our parallelogram symbol. Because in math, we want to shorthand it as much as possible, so you don't have to write out the whole word from now on. Okay? So what we're getting ready to do now is look at beyond this. Beyond this definition, what are some special properties? We're going to develop those different theorems, maybe about sides or angles, diagonals. What are some things that also are special about a parallelogram? So we're going to do a little investigation, and in your group, each person is going to end up making a different parallelogram. Okay, so you're going to be drawing a parallelogram on the grid. So before you do that, there's kind of some specific ways that we're going to go through to make sure, one, that everybody has a parallelogram, and two, we're going to make sure everyone in your group has a different one. Because I want you to investigate not just the same shape, because if everybody has the same parallelogram, they would all have the same angles and things. We're going to look at different shapes within your group. So when you go to draw a parallelogram on the grid, we know that a parallelogram has two sets of parallel sides. So to be sure that both sets of opposite sides are parallel, we have to think back to slopes of parallel lines because we're working on a coordinate plane on a grid. What do we know about the slopes of parallel lines? They're the same, right? Do parallel lines have the same slope?
Yes.
Sure. So, shut that down real quick. We already know parallel lines have the same slope. So what we're going to do is we're going to end up being sure that we draw lines that have the same slopes. So I'm going to walk you through the first 4 steps to develop your parallelogram, and then you guys are going to break into groups, and that's when you're going to do your investigation. Okay, so for step 1, it says we're going to use these lines on the grid as a guide and a ruler, and by ruler, I just mean a straight edge. So I'm going to give you your group's materials, and we're just using the straight edge of your protractor right now. So in each group, you can go ahead and get your materials and separate your jobs right now for each group. And if your group only has 3 people, remember your recorder and your presenter is the same.
I wasn't saying what it was. I was saying they had some.
Alright, so first, like I said, we're going to all develop our parallelograms first, and then you'll start doing your group part with the investigation. So let's make sure we get parallelograms set up the right way. So right now you're going to use your ruler and the lines on a grid. It says to draw a pair of horizontal lines that are any length apart on your grid to create just 2 sides of your parallelogram. And we're going to just draw long horizontal lines right now. You'll end up shortening the sides later. So watch first. I'm just going to take anywhere on my grid. I'm going to use these horizontal lines that are there and my straight edge. And I'm just going to make one really long horizontal line. And then anywhere else on the grid, maybe I stop only after a few rows. Or maybe you go all the way towards the bottom of this, but you're going to draw another horizontal line. And eventually, those are going to become 2 sides of our parallelogram.
Dang, that's a big one.
Okay, so yours are any length apart. And you can kind of look around in your group. You don't all want to make them the same length apart. You can investigate better. Anywhere on this grid, any 2. Okay. So remember, it's a parallelogram, right? So we need parallel lines. Are these horizontal lines parallel?
Yes.
How do we know that?
But
they don't touch.
Straight.
They're not touching. Would they ever end up intersecting?
No.
No. Let's go back to what we said though, guys. Parallel lines have the same slope. So what do each of these horizontal lines have a slope of?
We're already erased that. I'll make it fast.
0.
Signing back said 0, up here I heard 0. Think about rise over run. Goes up 0, over 1, up 0, over 1. So we know they are parallel because horizontal lines have a slope of 0. So the 2 lines we drew have a slope of 0. Now, if we read step 2, you are going to choose another value for a slope. So any other number besides 0. Maybe it's a half, 2/3, 4/5, 5, 3. You can always do like 3 over 1. However, this is where you have to start kind of communicating with your group because each member of your group should choose a different slope because that's going to ensure you each have a different parallelogram. So like for instance, I can pick a slope of 5. So I would want to let my group know, hey, I'm going to choose 5, or I can use 5 over 1. So just have a little mini chat with your group, let everybody know what number you're picking, so you all pick different slopes.
What I do? What?
Now that you have a slope, it says using that slope, you are going to draw a line that intersects both horizontal lines that you already have drawn using that slope. So for instance, I chose 5. So what I would want to do is I would want to make another line with a slope of 5. So I could start maybe at any point along the bottom. And it's okay, these horizontal lines, we're only going to end up using part of them. So maybe let's say I start here. And I go up 5 over 1. And I would just get a few points to make sure I intersect this line. Notice, mine doesn't exactly hit my other horizontal line, that's fine. Because I'm just going to draw a line connecting those points
Oh
You
man.
want us to start 2 off into the line?
that intersects those. You can really start anywhere on your line. Okay. So for step 2, to finish up step 2, you want to use your slope to intersect both of those horizontal lines. So we just finished up step 2. Okay. So if we go back to step 2. In step 2, it said we use that slope to draw one line that intersects both horizontal lines. Remember, we're making a parallelogram. We need 2 parallel lines, another pair of them. So we need to make another line that's parallel to this. So if we read step 3, we need to draw another line with the what? Same slope as step 2. So I chose 5. Somewhere on here, I'm going to draw another line with a slope of 5. So you can start anywhere. Maybe it's kind of close to your other marks. Maybe you're going to move it a little further away. I can pick a point anywhere on here, and again, use that same slope to make the last line, the last side of my parallelogram. What's different about yours?
Wait, which one's positive?
Now, step 4 is probably the most important right now. It says to label your parallelogram fish, or F-I-S-H. What is the most important part when I go to label?
Put it in order.
Put it in order. Now, I have some extra little segments. Are those part of my parallelogram? No. So just make sure, like, this is really right here, my end
Can we
point.
erase that shit?
You can if you want.
Okay.
You're going to end up measuring angles later, so you might have to extend your sides to measure your angles. So you might end up just extending them too. So, but you can. Make sure you use each vertex. We're going to label F-I, this would be S for me, my H is over there.
How do you know which one's S and which one's H? The
So-
order, right?
It doesn't really matter where you start, but how do I know, like, if I put F-I, could I put S over here?
S.
No.
Can we put S over here,
Go
guys?
in order.
Because you have to keep it in order, either clockwise or counterclockwise. So, like, I went around clockwise.
Oh, okay, so that's good. So,
Okay, that's the most important part when you're
So you
ordering.
could put F for your S's and
Sure. And then as long as you go around either clockwise or counterclockwise, it's fine. Alright. So at this point, everybody should have their parallelogram set up. Okay, so in your group, each person has your job. So facilitators, you're keeping your group on track, keeping the volume down, making sure only one person's speaking at one time, restating things. Also, right now, it's about 1:37, 1:38 just now. So we are going to come back together as a whole class at, we'll say, 2:05. Okay, so you have just over 25 minutes to do the investigation. So as facilitator, you want to keep that time paced as well. Reader, making sure you're reading everything to the group, maybe rereading things, pulling them back on track. Recorder, make sure you're jotting everything down on that group's log so that's who I'm coming around to check, to make sure your group is on track. I'll be communicating with you and presenter. You are making sure you're part of all of it, because when we do the group presentation, you need to be able to explain not just what's on the record sheet, but why. Like, where did it come from? Why was it that answer? Okay, so any questions about your jobs? About 2:05, so you have about 25 minutes. On the back is your investigation, so if you look at number 1, your readers can go ahead and get started with your
Yeah.
Finally, consider the fact that constructive diagnosis on your
that's part of the list is the opposite side.
Finally, let's consider
You asking about the opposite side or okay. Because you are right. Okay, you are very correct. Opposite sides are parallel. And that's part of our definition. But in number 3,
No, I'm not the person. 2.5 miles. And another one, 2.5.
using your ruler, what do you have to
Next one.
I can read.
Okay.
Even though if you have the name.
We're looking at I want to know, like, what's something like there? You're right. So go back and look at
Is this
Come on. She read all of it. We're doing it. I'm talking about you know what? So we got
even though if you have one right there.
What are you supposed to read?
right. You said
The label that yeah, I have that here. No, we don't want to know what you said.
okay, so y'all came up with, this is true, like you found that M is the midpoint. So thinking about that and using geometry vocab, right? So here, you're also saying in conclusion that they do what? Bisect. Cut each other. This is the midpoint, right? Because these pieces of these are equal. So, and that doesn't just happen with one. You said it happens with both, right? So that's actually a property that you're investigating. When you finish that sentence, you said that the diagonals of a parallelogram do what? Alright, so y'all are saying this is right. draw the diagonal? So, like, if you want to say, if we say that they're congruent, what we're saying is that, okay, just in general, like that would say this whole diagonal is the same as this whole diagonal. The whole entire length. Is that true? But these two parts are congruent, which is why you said this is the point. And that is, so I agree. So now try to think about something that you can say that this diagonal, how does this diagonal relate to that one? Or what do they do?
They're both equal the same moment.
Okay, so that's something you can say. That's something you can say. Okay, so like y'all can come up with that. If all of our presenters can come up here, bring your little record sheet, and if I can get my presenter from each group, just come up to the front so we can see what you have. So diagonals, we kind of came up with something different for each group. So Mohammed, what did your group say about your diagonals?
Are not congruent.
Okay, the diagonals are not congruent, meaning one diagonal, I'm just get y'all to kind of park for a second, maybe this way. When you drew your diagonals and they met at point M, was this whole diagonal HI the same length as this one FS? Like the whole thing? Now, maybe one was, hers was, but was everyone in your group's whole diagonal congruent? So yeah, no. Because it does happen sometimes. It's a special type of parallelogram that you ended up having, but was everyone's diagonals always congruent? No. So that's right, they're not congruent, but let's look at what are they. Like some said, earlier you guys said that the diagonals what? Had the same midpoint, and I think some other groups said something like that. You guys said have bisect one another. That's different. Dallas, y'all said they share the same midpoint. Emily, y'all said that they intersect at their midpoint. Okay, and you guys also said that they bisect each other. So if they have the same midpoint, what does bisect mean? Have two congruent parts. Will they have the same middle? Okay, so for a good like geometry vocab definition, yes, they do have the same midpoint, which means those diagonals actually bisect each other. Okay, they cut each other in half basically. So, all right, thank you presenters. Y'all can go erase your board, sit back down with your group. We just developed those properties and theorems about a parallelogram. Now let's actually put them to use. If number 11 gives you that segment AC and segment DB are diagonals of a parallelogram, A, B, C, D. And then they want you to find each one of these measures. So you have to find the length of AC, EC, DE, and EB, only knowing that these two segments are diagonals. Well, you just discovered something about the diagonals, right? So I'm going to kind of zoom in on this picture just to show you. These are lengths of the pieces of the diagonal, like just DE is x plus 1. The 3x minus 13 goes with EB. Okay, and then the other diagonal is 8C. So the 2y goes with AE, and then the y plus 5 goes with EC. Okay. The second picture for number 12 is giving you, you're going to make sense of some of these problems. It's giving you a floor tile that Mr. Cortez is selling. You remember he's got all those different quadrilateral tiles. And he needs to know which ones are which shapes so he can sell them correctly. So one is shaped like a parallelogram. They want you to find the measures, all of these angles, and then these side lengths of this tile. So with your group, you're going to use those properties that we just came up with today. And when we go over this, I'm going to get presenters to kind of tell me why or what property are we using. So as we go through, not only do you answer the question, but you need to know what property are you using to help you answer that question. Okay, so guys, just finish up numbers 11 and 12 there. As a group, talk about it, discuss it. So let's go back. DE. How do we find the length of DE? Dallas, what did you set up for that?
I did x plus 1 equals 3x minus 16.
Which is true. Why, though, does x plus 1 equal the 3x minus 13. Why can we set up this equation, guys? There's a theorem that we came up with about our parallelogram. What's true about these diagonals? They do what? Everybody tell me diagonals do what? Okay, so if they're bisecting each other, D is a midpoint, so this segment, DE, is congruent to segment EB. So for number 12, if they're giving us only 2 angle measures, now be careful because the other ones are side lengths, right? We know these are angle measures because they're in degrees. So if x is b plus 15 and y is 2b, now a lot of people I was walking around and we had the discussion about, you knew that x and z are congruent because they are opposite angles, right? And y and w are also congruent because they're opposite angles. But what do we call angles x and y? They are supplementary because they're which type? Consecutive angles. So if they're supplementary, who can give us an equation that we can set up with those 2 angles? Hannah?
2b plus b plus 15 equals 80.
Okay, she said that 2b plus b plus 15 equals 180. And that's in degrees, so is that true?
Yes.
Yeah, because they're supplementary. When you solve that, what did you find for b, Hannah?
b equals 55.
55? Okay, your whole group had that. Another group, did we all get 55?
Yeah.
Okay, did anybody solve that and get 55 for b a different way?
No.
Catherine, what did you do?
I multiplied b plus 15 times 2, and I multiplied 2b times 2.
Okay, so she said
60.
2 of these b plus 15 and 2 of these 2 b's, or the value of y, all equaled what?
360.
360. Why would you do that?
Because the basic guy and
Because a quadrilateral equals 360, right? So why did she need 2 b plus 15s? 2 of these, meaning x and what other angle equals that? Z, right? And the same for 2b is also the value of w. Can we do this?
Yes.
Yeah. And Catherine, when you solved, you also got 55? Good. Who feels like today they were able to develop some properties of parallelogram? Okay, and who can use those properties to solve problems? Okay, so one last thing before we leave, and this is what I'm collecting as your exit ticket. I want you to look at, check your understanding, so on a sheet of loose leaf, jot this down, numbers 8, 9, and 10. On a sheet of loose leaf, I want you to answer this without the help of your group now, okay? We're gonna just check to make sure everybody really understands these properties today.
So then we have to copy it down to
You can just put your answers in. I'm gonna pick that up, okay? So on your own, on a sheet of loose leaf, you're answering numbers 8, 9, and 10. And then when you finish with that, you can come turn it in the tray, and then you can actually start working on your homework.